Hello everyone, welcome back to this training series on ISA IEC 62443 framework on industrial cybersecurity training. In the previous episode, we introduced the fundamental of industrial cybersecurity and discussed why protecting operational technology system is critically important. But understanding the problem is only the beginning. The real question is, how do organizations systematically secure industrial system across large industrial environment? This is where international cybersecurity frameworks such as ISA, IEC 62443 become essential. In this second episode, we move from foundational industrial cybersecurity concept into the formal governance structure behind industrial security, and we will examine the ISA IEC 62443 framework, its purpose, structure, lifecycle approach, and how it defines responsibility across stakeholders. Understanding this framework is essential not only for certification preparation, but for applying structured security principle in real industrial environment. So let's begin by understanding why such a framework is necessary. Let's start with an important question. Why do we even need cybersecurity standard for OT environment or operational technology environment? One major reason is a growing number of cyber attacks targeting industrial control system and critical infrastructure. And secondly, there is what we call that operational complexity. This is another challenge since industrial automation and the control system operate under strict performance and safety constraints. They have their own unique technical constraints. Because of these constraints, traditional IT security control cannot always be applied directly. The third reason why IT security standard is necessary is that organization also need a consistent security practice so that different vendors, operators, and integrators follow the same security methodology. So, uh, to form a uniform methodology across diverse industrial environment, we need an OT security framework. The final point is industrial cybersecurity must align with safety and reliability of the requirement. Since they require an integrated alignment, that means coordination between safety, reliability, and cybersecurity to ensure operational integrity without compromising security. So, standard provide the structured guidance needed to achieve all of these goals. So, what's exactly ISA IEC 62443? In previous discussion on section 1, we have already generalized where ISA IEC standard comes from and what's the purpose of our framework. Now, let's see what's exactly IEC/IEC 62443 is. This framework is an internationally recognized cybersecurity framework designed specifically to protect industrial automation and control system. The framework evolved from the ISA 99 Security Commission, which originally developed the standard, and then later on, the framework was adopted jointly by ISA and International Electrotechnical Commission, giving it a global recognition. So, unlike many IT security standards, this framework specifically work on industrial automation and control system across their entire operational life cycle. That means IACS, which is specifically designed to secure those automation or industrial automation tools that we have already discussed on session 1, like PLC, HMI, SCADA system, or distributed control system, DCS, and other sensors and actuators. So they are specifically designed to secure IACS, unlike other IT system. And also it provides comprehensive technical requirement and best practice for securing industrial environment. This makes it one of the most important cybersecurity framework for critical infrastructure environments. So next, let's see what is the purpose of this framework. Now we understand what the framework is. Let's examine its purpose. ISA IEC 62443 define structured security requirements that apply to industrial system and components. So the first purpose is a structured security requirement. It also defines roles, responsibilities to ensure accountability for cybersecurity implementation. Second purpose is role and responsibility to establish accountability framework and clear ownership for security implementation and maintenance. Next is risk-based implementation. This is the key principle, which is risk-based implementation, where security control are aligned with operational risks. This promotes security measure aligned with identified risks and operational impact assessment. Next is defense in depth. Finally, the framework supports defense in depth strategies, meaning multiple layers of protection are implemented to defend against cyber threats. So together, this principle provides a systematic approach to securing industrial system. Next, the structure of ISA/IEC 62443 series. One important thing to understand is that this framework is not a single document. This is not a single document. Instead, it's a series of standards organized into several categories. The framework includes four major groups. They have four major groups. The first is 62443-1X, which is a general concept and terminology. Next, 62443-2X series, which mostly concern with policy and procedures. Next, 62443-3X series, which is system security requirements, deals with system security requirement. And the final 62443-4X series, which is a component security requirement. So let's examine each of these categories in more detail. As you can see from this slide, 62443-1X is a general, as foundational concept, terminology, and models, while 62443-2X series is all about policies and procedures, organizational security management requirements, while 62443-3X series is system requirement security specification for industrial system, while 62443-4X series is component requirement, that means technical security standard for products. So let me see each in detail. Before organization implement cybersecurity control, what must they establish first? What is the necessary thing they should establish first? Answer is a shared understanding of cyber security concept. The first thing that organization should implement for cybersecurity control is a shared understanding of cybersecurity concept. This 62443-1X series focus on terminology, definition, and conceptual models because this ensures that vendor and operator, system integrator, and security professional use the same vocabulary and framework concepts. So they need to define terminology and definition. That means standardized vocabulary, ensuring consistent communication across all stakeholder and technical documentation, while the conceptual model is framework architecture and security concept providing common understanding of industrial cybersecurity principles. So the common foundation is that shared baseline enabling collaboration between system integrator, vendor, operator, and security professional. In other words, this series provides the common foundation for industrial cybersecurity discussions. Next, about policy and procedure or 62443 2X series. Technology alone cannot secure an industrial environment. The 62443 2X series focus on cybersecurity governance and management practices. This include organizational security program, risk assessment, and incident response planning. It also defines roles, responsibilities, and decision-making authority for cybersecurity activities, operational process such as responsibility, decision-making authority for cybersecurity activity. So this policy and procedure standard or the second 2X series includes organizational security management. That means establishing a governance framework and management structure for what? For implementing cybersecurity program across OT environments. While the next is securing program requirements. That means it should define mandatory elements including risk assessment, other organizational security programs, and incident response plans for what? For continuous improvement of cybersecurity posture. Next is governance process, which classifies role, responsibility, decision-making authority for security-related activity and policy enforcement. So this will define authorities who are responsible, who are accountable for each activity in incident response or other cybersecurity activities. The next is operational process. This defines a day-to-day security operation, including access management, change control, and security monitoring procedure. So in general, this series ensures that cybersecurity is managed as an ongoing organizational process. The next is 62443 3X or the third series. Now let's move into technical aspect of industrial cybersecurity. The 62443 3X series focus on security requirement for industrial system. The first is security requirement for industrial system. That means technical and procedural requirement ensuring secure deployment and operation of industrial automation control system environments. That means applying security requirement to each programmable logic controller, to each SCADA systems, to each actuators and sensors, to each distributed control systems. This requirement ensures that industrial automation environments are designed and deployed securely. Example includes, for example, if you take this as architectural level consideration, we can take network segmentation, security zones, access controls, and secure communication pathway will be consideration for system requirement or security system requirements for our OT environment. Next is risk alignment. Security measure should proportionate to identified risk and criticality of protected industrial process. Well, many of the architectural concepts discussed in our next video originate from this part of the framework. So now let's finalize the fourth series. Next, let's move from system design to the security of individual components. The fourth is component requirements. The 62443 4X series defines security requirement for industrial components such as PLC or programmable logic control, HMI or human machine interface, and other network devices. It also defines secure development lifecycle practice. This means the development of practice ensuring security is integrated throughout product design, implementation, and maintenance phases. This will include technical capability requirements such as authentication capabilities, encryption mechanism, logging, and secure software updates. So, this requirement ensures that industrial products are developed with security integrated from the beginning. So, this requirement ensures that our industry or our OT environment products are developed with security that is integrated from the beginning because it will increase our layer of protection. Now let's move to the life cycle approach. Let me ask you something. Is cybersecurity something that organization implement once and then forget? Do you think that cybersecurity or other security mechanism or security approach are something that organization implement once and then forget? The answer should be absolutely not. Our framework ISA/IEC 62443 emphasizes a life cycle approach to cybersecurity. That means security must be integrated during system design, during implementation, during operation, during maintenance, and during continuous improvement. For the design, security requirements are integrated into system architecture and component selection. That means starting our cybersecurity activity from the beginning. Then next, during the implementation, it should follow safe or secured configuration and the deployment of system and components. Next, during the operation, continuous monitoring and security control enforcement is needed while operating. And next, while maintaining regular updates, patches, and configuration management should be applied. The next important thing is improvement. Continuous learning, continuous enhancement is required. So, this whole life cycle approach should be implemented in our operational technology or OT environment to secure our industrial operation. Security is not one-time project, but it's a continuous process requiring ongoing attention, assessment, and improvement throughout the system lifecycle. This ensures that cybersecurity evolves alongside industrial system. Next is about defining roles in standard. Another important concept is clearly defining responsibility. This standard identify three primary stakeholders: asset owner, system integrator, and product supplier. Each party has specific security responsibilities throughout system lifecycle. The asset owner are responsible for defining security requirements and maintaining system protection. The major activity of an asset owner is that to ensure the security of the requirement, or to define what are security requirement and to maintaining the protection of the system. Next, system integrator. This second actor translates this requirement into technical implementation and also ensure proper implementation during system integration. Next one is product supplier. This develops secure components and maintain security updates. These product suppliers develop and deliver secure components that meet specified requirements and provide ongoing security maintenance. This shared responsibility model ensures accountability across the entire industrial ecosystem. You should remember that we are dealing with defining role in ISA IEC 62443 framework. So we have already defined our roles into three: asset owner, system integrator, and product supplier. So this shared responsibility model ensures accountability across industrial or OT environment or ecosystems. Next is risk-based security model. This is the key principle within ISA IEC 62443, which is risk-based security. Risk-based security model, which ensures security requirement driven by risk assessment. That means security control are determined through risk assessment rather than simple checklist. Security control must be determined through systematic risk analysis rather than list of checklists. So it should have a determined systematic risk analysis. Security measure must align with both the likelihood of an attack and potential impact on our operation. Since not all systems require the same level of protection or priority, security measure should be proportionate to the potential impacts and the likelihood of security event, and also alignment between threat capability and security level. Protection measure should correspond to the capability of potential adversaries, because this approach ensures that resources are allocated effectively while maintaining operational safety. So this is our risk-based security model. Now let's give you an example on purpose of ISA IEC 62443 in real world example, step by step using a diagram. Now we will see a colonial pipeline cyber attack, which is a ransomware shutdown a major fuel pipeline in 2021, affecting critical infrastructure supplying fuel to the eastern US. This incident demonstrates why industrial environment require structured cybersecurity framework such as ISA/IEC 62443. Let us zoom this. Well, this attack began with very common cybersecurity technique, which is phishing. In this case, attackers were able to obtain a compromised password belonging to the unemployed account. The first step of this attack is phishing. In this case, the attackers are able to obtain a compromised password belonging to the employee that works in this pipeline activities. Then the credential which is gained through phishing allows the attacker to gain access to the system that are connected to the organization network. What is important to understand here is that many large cybersecurity incidents began with something surprisingly simple, which is a stolen credential. This highlights the importance of identity security and access control, which are a critical component addressed in industrial framework. Second is a remote access entry. First is employee phishing, email, password stolen via phishing. Second, remote access granted. Hacker infiltrates an OT network. Hacker infiltrate operational technology network. So now let us see remote access entry. After hacker obtaining the stolen credential, the attacker were able to log into the remote access system used by the workstation or used by the organization. This allowed them to enter the company internal network. In many industrial environments, remote access is necessary for maintenance, monitoring, or system administration. However, if remote access systems are not properly secured, for example, without multi-factor authentication, they can become an entry point for attacker. This stage demonstrates why secure remote access control and network segmentation are essential in operational technology environment. In step 3, ransomware is deployed. Once inside the network, the attacker deployed a ransomware malware. Ransomware encrypts system and prevents organization from accessing critical data and infrastructure. In this incident, the ransomware affected systems that supported pipeline operation. Even though the operational technology systems themselves were not directly damaged, the organization decided to shut down pipeline operation as a precaution or as incident response. This decision shows how interconnected IT and OT environment can be. When IT systems are compromised, industrial operation may still be forced to stop. Next stage is, or the fourth is fuel pipeline shutdown. As a result of cyber incident, the company temporarily shut down the pipeline. This pipeline is one of the largest fuel transportation system in the United States. It supplies approximately 45% of fuel used along the East Coast. When the pipeline stopped operating, the effects were immediate. Now, this shutdown triggers a real world impact. What are these real world impacts? Fuel shortage. Now, fuel shortage began appearing in several states. The gasoline price increased, and many people began panicking, or people began panic buying fuel. This incident demonstrated something that is very important. So, cybersecurity incident affecting critical infrastructure can quickly escalate into economic and social disruption. So, this is exactly why frameworks such as ISA IEC 62443 exist. This standard provides guidance on how organizations should design and secure their industrial architectures. This includes network segmentation, access control, monitoring and detection, and risk management. So, when organizations follow structured cybersecurity framework, they significantly reduce the risk of incidents like this. Now, the question becomes, how do organizations actually design industrial network that can resist cyber attack? To answer that question, we need to understand the architecture principle defined in our framework, or in our ISA IEC 62443 framework. At this stage, we have covered the structure and the purpose of ISA IEC 62443 framework. To reinforce these concepts, let's go through several certification style questions. These are designed to help you test your understanding and also prepare you for the IC32 exam format. I recommend that you pause the video for a moment when each question appears and try to answer it yourself before we review the explanation together. So let's begin with our first question. Question number one: which statement best describes the primary purpose of? Well, question number one: which statement best describes the primary purpose of this framework? A. Replace IT security standards. B. Provide structured cybersecurity governance for industrial system. C. Mandate firewall configuration. D. Standardize industrial operating systems. Now, take a moment and consider which answer best reflects the role of ISA IEC 62443 framework. Take a moment. I think this is an easy question. So, the correct answer is B, which is provide structure cybersecurity governance for industrial system. For industrial system, or industrial automation and control system, IACS. This system operates very differently from traditional IT environments. They interact with physical equipment, control industrial process, and often run continuously for many years. Because of this operational constraint, ISA IEC 62443 introduced a structured governance, technical requirement, and clearly defined responsibility for protecting industrial environment. So the correct answer should be B, which is our framework provide a structured cybersecurity governance for industrial system. Now let's move to the next question. Next question is about uh, organizational security management process, which ISA IEC 62443 series focus on organizational security management process. Option A 62443 1X series. Option B 62443 2X series. Option C 62443 3X series. Option D 62443 4X series. Now think about which part of the standard addresses policy, procedure, and organizational security program. Now take your time, take your moment to answer this question we have already discussed in our presentation. So the correct answer is option B, which is 62443 2X. This series focuses on organizational governance and security program management. It includes guidance on establishing cybersecurity policies, implementing on risk management processes, managing incident response procedures, and maintaining ongoing operational security programs. In short, the 62443 2X series define how organizations manage cybersecurity at a strategic and operational level. Now, let's look to the next concept. Question number 3. What distinguishes ISA IEC 62443 from many IT framework? What makes ISA IEC 62443 unique from other IT frameworks? Option A eliminates risk assessment. Option B focuses only on encryption. Option C designed specifically for IACS or Industrial Automation Control System. Option D mandates identical control everywhere. Again, now take your moment to answer this question. The correct answer is option C, which is designed specifically for industrial automation control system. Traditional cybersecurity framework primarily address enterprise IT network and information systems, while industrial environment controls physical process such as manufacturing line, power generation, and critical infrastructure operation. Because of this unique requirement, ISA IEC 62443 provides a framework specifically designed for operational technology workflow environments where reliability, safety, and continuous operation are critical. So the correct answer is our framework is tailored specifically for industrial automation and control system environment. Now let's continue to the next question. Well, next question states that which statement reflects the life cycle principle? Option A, security only during deployment. Option B, optional during maintenance. Option C, integrated across design, operation, and improvement. Option D, indus after commissioning. This is easy. Take, take your moment to answer this. The correct answer is option C, which is an integrated across design, operation, and improvement. Security must be continuous across the full system life cycle. One of the key principles of ISA IEC 62443 is that cybersecurity must be integrated throughout the entire life cycle of industrial system. Security begins Security begins during system design, then continue during deployment and operation, and must be maintained and improved over time. This lifecycle approach ensures that system remain secure as technology evolves and new threats emerge. Now let's move to the next question. Who retain ultimate responsibility for defining security requirements? This question says, who retain ultimate responsibility for defining cybersecurity requirement within an industrial environment? Option A, product supplier. Option B, regulatory authority. Option C, asset owner. Option D, system integrator. We have seen this in roles and responsibility session. We got three roles and responsibilities. So, which option retain a responsibility for defining security requirement? Again, now take your moment to answer this question. Take your time. The correct answer is C, which is an asset owner. The asset owner operates the industrial system and therefore retain responsibility for defining security requirement and managing operational risk, while system integrator implement architecture and product suppliers provide secure component. The asset owner is ultimately accountable for ensuring appropriate cybersecurity measures to the OT or industrial environment. Well, next, let us move to the practical scenario questions. An energy generation company deploy a new turbine control system. The asset owner defines security requirement but assumes that the system integrator is responsible for long-term cybersecurity monitoring and policy enforcement. Over time, security responsibility become unclear, leading to gaps in incident response. So, which ISA IEC 62443 principle was not properly applied? Option A, defense in depth. Option B, secure development life cycle. Option C, clear roles and responsibility definition. Option D, encryption enforcement. Now take your time to answer this. Take your moment. The correct answer is option C, which is clear role and responsibility definition. ISA IEC 62443 clearly define stakeholders. ISA IEC 62443 clearly define stakeholder responsibilities among asset owner, system integrator, and product suppliers. When these responsibilities are not properly defined, organization may experience governance gaps that lead to security weakness. So, the asset owner retain responsibility for defining and maintaining security requirement. Ambiguity in role separation violates governance principle within our framework. So the correct option is C, which is clear role and responsibility is violated. Now here is our final scenario. A manufacturing facility applies identical security control across all industrial systems, including low impact monitoring station and high criticality production controller without conducting a formal risk assessment. You have to know that without conducting a formal risk assessment. So, which key principle of ISA IEC 62443 is being ignored here? Option A, life cycle integration. Option B, risk-based implementation. Option C, component certification. Option D, network redundancy. Take your moment to answer this. Which is which key principle is ignored here? The correct option is option B, which is risk-based implementation. Which is risk-based implementation. The ISA IEC 6443 require organizations to evaluate risks and apply security control proportional to criticality. I will repeat it. Our framework requires organizations to evaluate risks and apply security control proportional to system criticality. This means applying identical control across all systems ignore operational risk difference and may lead to ineffective security strategy. So the correct option is option B, which is risk-based implementation. Excellent work. This question highlights several key principles within our framework, including governance, life cycle management, stakeholder responsibility, and risk-based implementation. So now let's finalize our today's discussion. What are the main takeaways from our today's discussion? So now let's summarize most important points from this session. Well, the first is framework provide a structured governance, establish systematic approach to industrial cybersecurity management. That means our framework ISA IEC 62443 provide structured governance for industrial cybersecurity, and also it clearly defines the responsibility across asset owner, integrators, and suppliers. That means clarify security duties across all stakeholders. It also supports lifecycle based security. That means apply security principles throughout system development and operation. Our framework supports lifecycle based security across system development and operation. Now, most importantly, it provides the foundation for implementing detailed cybersecurity control, serves as a basis for implementation of detailed security measures. Now that we understand the structure of ISA IEC 62443, now we can begin exploring how these principles are implemented in real industrial environment. In the next session, we will examine zones, conduits, and risk-based segmentation, which are essential architectural concepts for protecting industrial network. This will take us deeper into practical implementation of industrial cybersecurity. So this is all about our today's discussion. Thank you very much for watching our videos. I will see you on the next session. Bye bye.